Today we are going to talk about how to find the point of intersection of a system of linear equation by our first method, which is graphing. Before we talk about different ways of solving it using graphing, we are going to just define some concepts here. We define a system of linear equations as a set which has two or more linear equations. Remember, linear equations are the ones that the variables x and y, for instance, they all have a maximum of exponent 1. Something like y equal 3x minus 2 or y is equal to 2 and so forth. These are called lines or linear equations. Now, if you have more than one linear equations, the two lines can be either parallel when they do not intersect. This means that your system of linear equations does not have any solution. They can cross only at one point, so there is only one point of intersection, or they can be on top of each other, like this case. In this case, you have infinite number of solutions. Now, majority of the questions that we are going to solve are the ones that they have only one solution. Now, when you graph the two lines, the point that they intersect is called POI, or point of intersection. So this point we call POI, which is the solution of the system of linear equation. Now, very important is that the POI has to satisfy both equations. And this you have to check after you solve any system of linear equations. Now, there are four methods for graphing a line. And these are the methods that we can use to solve system of linear equations by graphing. The first one is table of values, where you are going to choose at least 2 points and then find the value of the other variable and then plot the points and connect them. The next one is the slope y-intercept, is when you have your line in slope y-intercept, then you can use this technique to plot the line. The third way is to use x and y intercepts, which is probably the easiest technique in graphing a line if you want to do it manually. And the last one is the technology. Now, either you can use TI-83 or TI-84, or you can use the online site like Desmos, which is going to be shown in this lesson on how to use that site to find the solution to a system of linear equations. But again, as usual, the best way to learn these techniques is to do it with example. So we are going to do our first example. Example 1 says you have two equations or one system of linear equation, y equal negative 3x plus 4 and y is equal to 3x minus 2. We are supposed to use table of values to plot the two lines and then find POI. Remember, when you are asked to use a specific method, only use that one. Do not try any other method. Now, let's start with the first line. Y equal negative 3x plus 4. As usual, I'm going to have a table of value like this one. XY. I'm going to pick my 5 points to be negative 2, negative 1, 0, 1, and 2. For each one of these points, I'm going to evaluate the first equation for y. So for x equal to negative 2, I'm going to get negative 3 times negative 2 plus 4, which is going to give me 6 plus 4, which is going to be 10. The next one is going to be negative 1. So it's going to be negative 3 times negative 1 plus 4, which is going to give me 7. The next one is 0, so I'm going to get negative 3 times 0 plus 4, which is going to give me 4. The next one is 1, so it's going to be negative 3 times 1 plus 4, which is going to give me 1. The next one is 2, so negative 3 times 2 plus 4, which is going to give me 10. Negative 3 times 2 is negative 6 plus 4 is negative 2. Sorry. Now we have 5 points, negative 2, 10, negative 1, 7, 0, 4, 1, 1, and 2 and negative 2. Plot the points and then draw the line. Negative 2 and 10, since it's outside our grid, we cannot plot this point. So I'm going to ignore the first and the second points. The third point is 0 and 4. So 0 and 4 is going to be this point. The next one is going to be 1 and 1 is going to be this point. The next one is going to be 2 and negative 2, which is going to be this point. And then what I'm going to do is that I'm going to draw the line going through these 3 points, which is going to be the line which is just drawn. Now I'm going to follow the same technique and I'm going to plot the next line, which is 3x minus 2. Again, I'm going to draw the table of values, which is x and y. I'm going to pick the points negative 2, negative 1, 0, 1, 2, and then I'm going to evaluate the value for y. When x is negative 2, I get 3 times negative 2 minus 2, which is going to give me negative 6 minus 2, which is negative 8. The next point is going to be negative 1, so I'm going to get 3 times negative 1 minus 2, which is negative 3 minus 2 is negative 5. The next one is 0, so I get 3 times 0 minus 2, which is going to give me minus 2. The next one is 1, so I get 3 times 1 minus 2, which is going to give me 3 minus 2, which is 1. And the last one, 3 times 2 minus 2, which is 6 minus 2, which is 4. Now the first point, like before, I cannot plot the point because it is y equal negative 8, which is outside the grid. So I'm going to try negative 1 and negative 5. When x is negative 1, y is negative 5, which is this point. When x is 0, y is negative 2, which is this point. When x is 1, y is 1, which is this point here. When x is 2, y is 4, which is this point. Now I'm going to go ahead and draw the line going through these 4 points. And then I'm going to, by investigation, find the point of intersection. The second line is also drawn, and by investigating the graph, it is obvious that this point is point of intersection, which is 1, 1. Now, as I said before, always remember to check the result to see if this point satisfies both equations. On the first equation, negative 3x plus 4 is negative 3 times 1 plus 4, which is negative 3 plus 4, which is 1, which is great because the point of intersection is 1, 1. The next one, 3x, 3 times 1 is 3 minus 2 is 1, which is also equal to y. So this shows the first method, which is table of values. Between all these 4 methods, this is the most time consuming one because you have to find, depending how many points you want to find, 5 points here, and the process is going to be the same anyway. So let's go ahead and do the next example. In this example, we have to find POI between this system of linear equation using slope y-intercept. To proceed with this technique, you have to find the slope and the y-intercept of each line. For instance, for the first one, the slope is the coefficient of x, and you can see the coefficient is 1, so the slope is 1. You always write the slope as a fraction, so I'm going to write this guy as 1 over 1, meaning rise is positive 1, run is positive 1, and the y-intercept is 2. For this case, the second one, there is no x term, so this means the slope, which is the coefficient of x, has to be 0. So I can write this guy as 0 over 1, and the y-intercept is negative 3. The next step is to start plotting the y-intercept of each line. So I'm going to start with the first line. The y-intercept is 2. Then the rise is 1 and the run is 1. Rise is positive 1, so I go 1 unit up and then 1 unit right because run is 1, so I get this point. Now what I have to do is to draw the line which connects these 2 points together. The line is drawn going through these 2 points. Now I have to plot the second line. The second line, again, the y-intercept is negative 3. So I'm going to start with negative 3, which is here. Then it says that the rise is 0. Look here. The rise is 0, so I'm not going to go up or down. I stay at negative 3, but the run is 1, so I go 1 unit to the right. So I'm going to end up with this point. So these are the 2 points that I have to draw the line going through them. The second line is also drawn, and you can see the point of intersection lies right here, which has x value equal to negative 5 and y value is negative 3. Again, remember to check the solution to see if it satisfies both equations. First of all, on the first equation, when x is negative 5, so negative 5 plus 2 is negative 3, which is correct. The second equation says y equal negative 3, which is the y coordinate of point of intersection. So the point of intersection satisfies the 2 equations. Now we are going to do the third example, solving system of linear equations using x and y intercept. This is probably the most easy method between these 3 methods that we are considering about graphing a line: TOV, table of values, slope y-intercept, and x and y-intercept. This method, x and y-intercept, the easiest one. Just to refresh your memory, to find the x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0. So, to find the x and y-intercept here, for the first line, I'm going to set x equal to 0, so I get y equal to 2. So that's the y-intercept. For x-intercept, I set y equal to 0, so I get 4x plus 0, which is 4x, is equal to 2. So x is going to be 2 over 4, which is going to be 0.5. And then I plot these 2 points and then draw the line. So y equal to 2 is 1, and the other one, x is equal to 0.5, which is going to be somewhere around here. And now I'm going to draw the line going through these 2 points. The line is drawn. Now I'm going to find the x and y intercept of the second line. So the x-intercept, again, we are going to set y equal to 0, so we get x is going to be 0. X is going to be 3. And then for y-intercept, I set x is equal to 0, so I get negative y is equal to 3, or y is equal to negative 3. So I'm going to plot these 2 points. X is equal to 3, which is this point, and y equal negative 3, which is going to be this point. And then I'm going to draw the line going through these 2 points. The line is drawn, and by investigation you can see that the point of intersection is right there, which has the coordinate of 1 and negative 2. Now, the last step is to check to see if the point satisfies both equations. The first equation says 4 times x, so 4 times 1 plus y plus negative 2 is going to be 4 minus 2, which is 2, which is correct. The second equation says x, we said that x is going to be 1 minus y, which is minus 2, which is 1 plus 2, which is 3, which is also correct. So this shows that the POI found is satisfying both equations. Now we are going to do the last example using technology. In this example, we have to find point of intersection of the system of linear equation negative 24 minus 8x is equal to 12y, and 1 plus 5 over 9y is equal to negative 7 over 18x. It is going to be a little bit hard using any of the graphing techniques that we learned before. Table of values, xy intercept, and slope y-intercept. We are going to use the site desmos.com to solve for POI. So I'm going to go online on this site, and then I'm going to show you how you can plot these 2 lines and find point of intersection. I have gone to desmos.com, and as you can see from the graphs, I have plotted negative 24 minus 8x is equal to 12y, which is in red, and also 1 plus 5 over 9y is equal to negative 7 over 8x, which is in blue. And as you can see, the point of intersection is going to be 0.22 and negative 2.147. This is an example of the problem or shortcomings of the other 3 techniques when you do table of values, slope y-intercept, x and y-intercepts to find point of intersection, because the point of intersection is not around a whole number. It's a decimal, and you can see from the graph that the value is 0.22 and negative 2.147.